This is a flip video about molecular equations. More importantly, it's about how to actually figure out what your molecular equation is now that we know how to calculate an empirical formula. So let's review for a second about empirical formulas. Remember, empirical formulas were not real formulas, they're the reduced ones. They're the lowest ratio of atoms against each other. So what's a molecular formula? A molecular formula is the real formula. So let's look at these two against each other to compare. We've got C6H12O6. That's the real formula. If I reduce this down, I get what's called the empirical. We've learned the empirical, so now we're going to take it one step further, and that is, how do I get the real equation using my empirical? So step one is figure out your empirical formula, which we learned how to do, and it's in a flip video. And now let's continue. Now that we have our empirical formula, how do we get our molecular? Okay? So again, these are some things you might want to make sure you have down in your notes. The difference between a molecular equation, it's the real equation, not reduced, and an empirical equation, it is not the real equation. It is the lowest ratio of atoms in the equation. Okay? All right, so in order to calculate the molecular equation, this is our basic formula. Okay? We're going to need two things. We're going to need two things to start. We're going to need the molecular molar mass and the empirical molar mass. Okay? So these two things, the molecular molar mass and the empirical molar mass, have to be given to you. You will definitely be given the molecular molar mass, and the reason why is because you're not given the equation. So you don't have a way to calculate it, so you need the actual mass. As for the empirical molar mass, you know how to calculate that. So keep that in mind as we begin. So again, we're going to start with two things. These are the two things you need to start with. If you don't have these two things, then you're really not going to know how to do them. Again, the empirical formula, so you can get the mass, and the molar mass of the molecular compound. Our goal is to find the molecular equation. All right, so going back to our equation, we will then determine between these two and get an n value, and we'll explain what that means in a second. Let's look at an actual problem to start this, and it says determine the molecular formula with an empirical formula of NH2 and a molar mass of 32.06 grams. All right, so again, the two things we needed to start with was an empirical formula. If you notice here, I have been given an empirical formula of NH2. Okay, so NH2 is my empirical formula. And I've also been given a molar mass of 32.06. Now, do not be confused. This is not the molar mass of the empirical formula. This is the molar mass of the molecular compound that I'm trying to find. Okay? So, again, just so you could see, the molecular mass was given to you. It's 32.06. The empirical's molar mass is not given to you, but you are given the formula. So can you find the molar mass of the empirical formula? Sure. Okay. All right, so let's do that. Let's find the empirical formula's molar mass. I have N, I have H, I have 1N times 14.01 grams on the periodic table. Just going to do a molar mass calculation. And I have 2 atoms of hydrogen times 1.008 grams of hydrogen on the periodic table. So I end up with, over here, 2.016 grams. Going to add these two together, and I end up with let's do correct sig figs. 16.026. When I add, I go to two place values, rounds up to 16.03 grams of NH2. Okay, now I have the molar mass of the empirical formula. Notice that needs to be calculated by you. Okay, they'll give you the empirical formula, but you have to get the empirical formula's molar mass. Okay, so now that I have that, let's see where this gets plugged in the equation. I use the empirical molar mass here on the bottom of the equation. Do I have the molecular molar mass? Yep, that's what this is. They gave it to me in the problem. Remember? The molecular mass was given to you right there. Okay? Careful with the wording because sometimes it can be confusing. That's why I purposely use this example. It is a little confusing. All right, so now that I have my information, I'm going to plug it into my equation. Okay? N is equal to molecular molar mass goes on top. Again, from my problem, that was 32.06 grams. And my empirical molar mass goes on the bottom. From my calculation, that was 16.03 grams. When I divide these two, I want to get a whole number. So no sig figs, get a whole number. And you should get a whole number. This won't be tricky. So N needs to be a whole number. So when I divide these two, so maybe you could take out your calculator and divide the two, right? Or maybe even in your head you could figure out a whole number. Hopefully you're saying when I divide those two, N is equal to 2, okay? This N is called a multiplier. What that means is I now have a number I can multiply against my empirical formula to get my real formula. So N times my empirical formula gets me my molecular formula. And here's what I mean by that. 2 times, well, my empirical formula was NH2. Okay, now, what this means is now I have 2 nitrogens, and 2 times 2 over here is 4 hydrogens. So N2H4. So this is a multiplier for my subscripts. That's what it means. Not 2 NH2s, but 2 times each subscript I have. N2H4. That is my molecular equation, my molecular formula. Okay? That's basically what you need to know. Go back and review that. Maybe take a second and see if you can calculate for that again. That's the end of the video.